Good morning, everyone. I'm Hamad Altaf. I'm part of the Solutions Engineering Group here at Gigamon, and I'm going to walk you through Gigamon's adaptive response application for Splunk. We did see Ananda discuss about the Defender Lifecycle model, and we saw Wasim talk about where time to act and time to decide is taking major portion of the incident response. And we saw Noam demonstrate how metadata generated by Gigamon could be converted into meaningful dashboards in Splunk. And identifying anomalies was pretty easy using those dashboards. Now, we're going to move to the next step, which is containment. Containment today, if you see, it's manual in most of the cases. We are going to see how we could automate it using Gigamon's adaptive response application for Splunk. This application leverages Splunk's adaptive response framework, providing administrators with actions they could bind and take on the visibility node via the GigaView Fabric Manager. These actions could be bound to the predefined searches which come along with Splunk Enterprise Security Suite, or the user could define a search and tag these actions to them. They could be triggered automatically using correlation searches, or could be executed via the notable events on the Splunk Enterprise Security Suite. Let's look at the actions we support today on this app. We have drop traffic. Gigamon's inline capability provides the administrator to drop the traffic right on the Gigamon visibility node. Here, we could use Splunk to identify rogue services or servers, and then instruct Gigamon FM to add a drop rule on the GigaView visibility node, so we could drop the malicious traffic right on our box. The next action is monitor traffic. In this case, we could tap the traffic and send a copy to a desired tool instead of dropping the traffic. Here, Gigamon could be inline or in outer band. Next action is sending a mail alert. Here, we identify anomalies using Splunk, and we send out a mail alert to the administrator identifying the anomaly. Now, let's look at the action fields we
as you mentioned dropping traffic there, a while ago, Gigamon was a visibility fabric, and you had tabs, active, passive, whatever, and then you were collecting and distributing that data. Are you now going into active filtering, so whatever you put inline can actually drop traffic?
Yeah, so I didn't mention that the inline capability provides the flexibility to the administrator. So the administrator could decide to drop the traffic right on this box, or could communicate to the firewall and drop the traffic there. But right now, because we are inline, we could drop the traffic right on our box.
Okay.
Is drop the only function you can do, or can you rewrite packets?
So we do monitor traffic, so where we can send a copy of the packet to a tool where you could analyze the traffic. So let's say you have a suspicious host, you identify that on Splunk, then you could send a request to the FM to add a monitor rule. So in this case, what would happen is anything going out from that suspicious host, you tap all the traffic from that host, just that host. So on the tool, you can just see that particular traffic and you could analyze it.
Okay, so you have tap rules, and then you have drop rules, but there's no rewrite rules.
No.
Yeah, so we cannot rewrite traffic today.
Okay.
The only situation when there would be any modification in the inline mode would be for SSL traffic when
you decrypt.
encrypted traffic coming in would be decrypted. So
Okay.
I wouldn't call that rewriting,
Right.
but obviously there's a transformation that's happening of the traffic.
Okay, thank you.
Sure.
How about transport for the redirected traffic?
Sorry, I didn't get you.
Transport, I would need an outer encapsulation to send traffic somewhere. Would you facilitate establishment of GRE, IPsec, or any kind of tunnel?
Yep, absolutely. So the traffic can be transported to a remote location, to a different destination that's not a physically adjacent host.
What encapsulation would you use?
So today we support, we have a Gigamon format that we call as Gigamon IP. We can also export that in layer 2 GRE as well.
There's no layer to GRE, it's an IP protocol, sorry.
Well, it's basically Ethernet over GRE.
Okay.
Yeah. So we've further added action fields, so you could decide whether to drop or monitor the traffic based on the source IP address or the destination IP address or particular destination service, or you could go for a combination of all these three termed as a transaction. So there could be many use cases. So let's look into one use case where we could have this in action. So here I'm going to demonstrate how we could identify rogue services in our network. Generally, you have your traditional monitoring tools monitoring what the administrator has configured. So rogue services in your network go unidentified. But Gigamon taps right on the network, so you see what the tools don't see. We send the DNS metadata to Splunk, and on Splunk, we do perform lookups to identify which is a legitimate server and which is an illegitimate server. Upon identifying an illegitimate server, we take an action to send an instruction to the fabric manager to add a drop rule on the visibility node. So here, we're going to see we have a HC2 here, which is our Gigamon visibility node being managed by the GigaView fabric manager. I'm placing the HC2 inline in the network, so I have clients on one side and servers on the other side. And then we have IPFix metadata being generated on our box and being exported to Splunk. So here, you're going to see that I'm going to log into a client, shoot out DNS resolution queries from my client to two particular DNS servers, one of which is registered into the network inventory, which I maintain on Splunk. So you would see that Splunk identifies which is legitimate, which is illegitimate, and then triggers an action to drop the traffic. So post this adaptive response, you will see that the client can access the legitimate DNS server and will not be able to access the rogue server.
Can this be done on the VM as well? I don't know what the right term is, but there's like the Gigaview VM that you could put in like VMware or whatever and send traffic to a promiscuous mode, or can that be in line? Maybe I'm totally off base. I could be. Totally
I'm not sure I understand the question.
I know. So there's a Gigaview VM.
Yeah, right.
Right.
Yes.
So can the VM do all of the stuff that this can do as well, or no?
No.
Okay.
The sorry.
Thank you. Sorry about that.
No worries.
For the video, because I think you're going to say something interesting.
Thanks for the question. So
Yeah.
just to make sure that we understand the question.
Yeah.
Your question is whether Gigaview VM can do what an HC2 does.
Right.
The question is no, it can do portions of it.
Okay.
We are adding more and more GigaSmart, what we call GigaSmart functionality
Okay.
into the Gigaview VM, especially for the AWS solution and OpenStack solution, and eventually also for the ESX NSX
Okay.
solution too.
Okay.
Today you can slice the packet to save on bandwidth. You will have to terminate the tunnel from the Gigaview VM onto an HC2, or HC3, HC1, any of our hardware devices, and then you could run it into metadata generation.
Okay. Makes
But
sense.
in our next version for AWS, we will have NetFlow generation right out of the V series in the cloud. In the public cloud, we call it the V series.
Okay.
So the V series will be able to generate NetFlow right off that device.
Okay. Cool. Thank you.
Is the assumption here that I'm going to put this device, because I've got this device in line already to capture traffic, that, hey, we can filter traffic, so why don't we just drop traffic? That's really, you're not going to position this as, okay, you don't have Gigamon, so let's put this HC2 in the middle of your network to do traffic filtering. It's more like, because you're capturing traffic and we have the filtering capability, let's add this little extra feature. Is that more how you would sell it to customers?
I would totally agree with you, Ethan. That's the right way to look at it.
Yeah.
That you use the power of the position to do that. So remember that the inline bypass capability that we spoke about, that's a very popular capability in the Gigamon platform. That goes back to your question in terms of, we were mainly in out-of-band mode before, but today it's as much about out-of-band and inline, right? So when you're inline, the next logical step to do is, use the power of that position that you have in the infrastructure to actually take actions on behalf of the detection and other tools that are out there.
But if you stay out of band, you can still, I guess, within the Splunk application, write the integrations to drop on a non-Gigamon
Yes, you can.
device or platform, right?
Absolutely, you can do that. Yeah. And that's why I'm not going to stand here and say that Gigamon is the only solution here, right? I mean, this is a pretty complex problem, and we all need to kind of fit into that ecosystem. Our goal here is to provide that model with the Defender Lifecycle model where all of the components can contribute towards that.
Right.
So in case you're out of band, you can definitely go ahead and monitor the traffic. So separately on a tool, you could monitor just that suspicious traffic. Before we proceed to the demo, I just like to talk about flow mapping technology which Gigamon uses. So people familiar with Gigamon visibility node know that we use maps to control the flow of traffic from source to destination. These maps have rules which function as a drop or a pass rule. So you can control which traffic goes further and which traffic does not go further. So here, we would be using Splunk to trigger drop and pass rules to control the traffic.
Can I ask you a question?
Yeah.
How would you deploy a solution in a data center with 128-way CMP?
Can you just come again?
How would they deploy your solution in a data center where most of the traffic is obviously east-west? I've got huge radix, so there's no way to capture single flow by putting your device somewhere. Is there a solution to put it as a container on a host and then consolidate view across different hosts? Because hardware-wise, I don't see how it can be used in data centers
That's
today.
what I was asking about the VM.
Yeah.
So in case we could...
It shouldn't be a VM, it should be something much more lightweight that could be on a VM.
Right.
Well, actually, when you look at the problem of DNS here, which is what you're focusing, right? There's no eight-way ECMP towards a DNS server.
128 mostly.
Well, not for DNS. I mean, DNS is usually pretty low bandwidth.
You have no idea how it's going to be hashed on the first, second, third switch.
Yeah, but the point to note here is that in order for us to do this specific function, you just need to be in front of the DNS server, right? You don't need to be kind of tapping in all the locations.
I'm done with pets. It's a kettle. It could be anywhere. That's the point.
What could be anywhere?
DNS server. And based on load, I might scale out, change IP address. Could be really anywhere.
It could be anywhere, no doubt about that. However, that's still a finite number, right? And that's the point. So in those specific locations in front of the DNS server, or wherever you see are the core locations where the DNS traffic needs to be captured, that's exactly where you'd be installing, a visibility solution like this.
DNS is only one of the sources of metadata. You want to see more stuff than just DNS, right?
Correct.
So my question goes back. You need to be on the host, not somewhere in the network. How would you do it? How would you consolidate what you see on every host?
In that
the minimum
particular
piece of
case, if it's a
information?
virtualized host, for example, so we can certainly have a solution for that there as well. That's something that we support today. That's what Noam was referring to.
Yeah.
And remember the other thing, right? That with metadata, I can collect it from my network just as it flows, right? So host A is making a request, whether it's DNS or DHCP or whatever it is. It flows through the network. Somewhere along the network, if I have a TAP or a GigaView VM on an ESX or OpenStack or AWS clients, I can collect that information from there and send it over to an HC2 and HC3 to create that metadata. So I don't have to be sitting right on the host generating the query.
The problem as your fan out grows, the chance of capturing this particular flow goes down exponentially, right?
Not necessarily. I mean, we have customers who are tapping, 1,000 critical links.
Good for
or
you.
More. So it is all about prioritization of, first of all, tapping the right locations in your network, your aggregations, your core links. You start with that.
I think that's his main point, though. Is
my
that
point,
scale out.
we have moved away from centralized firewall in front of data center, and everything goes through it, so it's quite easy. It's single way out. Now most of the traffic is within the data center, and you just don't see it unless you're on the host itself. You need to follow this communication.
So we do have, as I mentioned earlier, a solution for the virtualized world where you would see the east-west traffic as well. And we could talk. Hit me after this.
Okay, sure.
It would be interesting to see you whiteboard a leaf spine network design, reasonable sized data center, and how you would deploy Gigamon in that environment.
So let's do that after this session. Happy to go through that. We actually have a lot of deployments where visibility into east-west traffic is critical. But let's get back to
So
what
to Terry's point, it's not enough to virtualize your appliance, right? It's going to have exactly the same problem as before. You need to create or to segment your appliance and be able to reconcile all the data and make it meaningful, which is much more complicated.
Yes, so we can take that
Sure.
after the the sessions we have planned for. So I think you like the demo.
Two quick question. Does it perform the duplication of flows?
Absolutely.
Okay. Is it a NAT aware? If I have a NAT box in the middle, is there a way to correlate the before and after NAT to understand that it is a single flow? So can you read a NAT table of a file or a route or something?
No.
We don't stitch flows right now.
Yeah, we don't go across NAT boundaries in the sense that we don't correlate the before and after for a NAT.
Okay.
So if I try to use unit service chaining solution, it has to be before NAT.
Or after NAT.
Yeah.
Yeah.
Yep.
Let me quickly take you to the GigaView. This is the GigaView Fabric Manager. So I'm going to navigate to my physical nodes. I'm going to go to node and quickly show you the maps. So we have a couple of maps here which control the flow of traffic. And we are going to see how the rules get updated on these maps. So you could see that in our inline map, we just have one rule which sends all the traffic. Now, I'm going to go to my client, and I'm going to shoot out request. So here, I'm going to use two DNS servers. So one is 99.8 and other is 99.11. 99.8 is a legitimate server as per Splunk. So we've added that in Splunk. I'm going to shoot out a request. We see that resolve. And then I'm going to shoot out another request to 19.11. So you see both of these have resolved. Now let me quickly jump back to Splunk. So in Splunk, while I've pre-configured my app, there's a one-time configuration which the administrator will have to do. So he'll have to go to the adaptive response application here. And this is where we would be mentioning about the add-on. So you would be mentioning the FM where we'll be using, the cluster ID on which the maps are, and the action would be taken. And in case you're going for an email, then you'll have to mention the credentials to use. So once that is set, we could go to enterprise security. So here, we use enterprise security solution. I would quickly like to go to content management and show you the correlation searches. So like I said, Splunk Enterprise Security Suite comes with predefined correlation searches, which you could use. Or you could use user-defined correlation searches. In my case, I'm going to go to a user-defined correlation search, which I've written for my rogue DNS server. See here, I've written a correlation search which looks for the IPFix addresses and searches which is legitimate and which is illegitimate. So I'm running it on real time. So if I just scroll down here, you could see a section which says adaptive response action. This is where you tag this adaptive response action which Gigamon app provides to the correlation search. So here you can see that I've already added it. In general, you'll have to click on this and then identify the GigaView FM actions. Here, you can see that the actions I was talking about are available. So you could drop traffic, monitor traffic, or send an email alert. And similarly, using the action field, you can decide which field to act upon. So it could be source IP, destination IP, transaction, or service. Now once done, you could save this. I'm just canceling it because it is already set up. And let me just go to incident review. So in incident review, what happens is whenever there's a search which results in an event, we have a search right now. We showed that there was a DNS query, and then it has come out. So whenever there's a search resulting in an event, we could come and see here that there's a notable event identified here. So if you just expand it, you could see that we identified a rogue DNS server, and it is, if you just scroll down, you can see that there's an adaptive response section where there was a GigaView FM action taken. And then you could see the status. In our case,
Is it possible as an action to capture the flow?
Yeah, we could do it. We haven't captured it, but you could see the logs to identify. So here, if you see the event, the action was triggered based on this event. So this event would show that the IP 11.99.99.1 was a rogue DNS server. So you could get that data from there.
Okay, but can I capture the flow with the payload, the whole packet, like a pickup or something, to export for further analysis?
Yeah, so that's the monitor traffic. So if you click on monitor traffic, so what would happen is, from that point onwards, you start tapping on that particular source of destination. So from that moment. So the first packet would be just metadata, but anything after that would be monitored on a tool. So you could connect any tool and see that.
Okay.
Can you set a threshold?
Yeah.
Because you get one request and it could filter it or take action. What if you wanted to set a threshold to say, once it sees it more than N
Yes.
times?
So all these goes as a search on the correlation search. So on correlation search, if you see, first thing, you will have to identify. Here, we've just used our IPFix data, but you could go for a little bit advanced searches where you could take the query name, go to sites like VirusTotal, identify if it is malicious, and then take the action. So it's all upon the search you build on Splunk. So you could correlate from different source indexes and build your correlation search. There you could tell if the event is more than 150 over a 5-minute period. And similarly, there's something called throttling. So you don't want incidents to just, suddenly there's a web request, you have a lot of packets going. You don't want adaptive response to just trigger on every single action. So we call it throttling. So you could set the throttling indicator that when an action is taken place, just wait for 2 or 3 minutes, or wait for a day for the next event to happen. So we have those options in the correlation searches. So let me just. So I don't see that record here. So I'll just quickly get into my search. See, here you can see the records coming in. So these are the metadata which is being exported. So I do see it from, see here, you can quickly go down and click destination IP address. You could select any fields and create a table. So I'm just going to quickly set this and check my event. So see here, you can see that the search has come for gigamon.com. And now, let me quickly go to the view. It generally happens that Splunk takes about a minute to index the data. So you have this metadata coming into Splunk, and Splunk takes a minute to index the data, which would be normal if you use Splunk. Suppose that 1 minute, you can see that the action gets triggered. So here, we take time. In me, I just click on. So Yeah. So you can see that there was an incident triggered, which is a rogue DNS server identified. So this action, if I just open it up, you could see that this is identified and this is success. Now how do you verify it? There are two things. First, let's get back to FM and just refresh it. You can see the number of rules have been updated in the maps. Now let me just quickly open one of these rules. And you can see that Splunk automatically added the DNS server here. Now, on the client side, let me just quickly go back to the client and show you that now, if you try to reach or send out queries to this particular DNS server, it's going to be blocked. But let's say you send out a query to the legitimate server, it still works. This is one of those use cases where we could use adaptive response to take action. So there are many other cases. For instance, you could act upon high entropy URLs. Here, we could see that when a user tries to access a high entropy URL, a suspicious site, you could start monitoring rule. You could add a monitoring rule on GigaView FM to start monitoring that particular device. So here, again, in this case, I would query a very lengthy URL of which the entropy is going to be high, and I've configured a threshold of 4. So here, I've set that parameter that in case the entropy is more than 4, this trigger out a request. So here, I've just set it up on my DNS server to resolve that. So in most of the cases, what happens was, like Noam said, the command and control centers are generally machine-generated domains. These domains are high in length. But this does not mean that it is suspicious, because there are many other URLs which could also be lengthy, and the entropy could be high. So in this case, we're not going to drop the traffic. We're rather going to monitor that particular host traffic. So here, I've just triggered out a request. And again, for the verification purposes, you can see currently, we do not have any rules in the out-of-band map. So this particular map sends the traffic from the inline network port to the tool port. Now, let me quickly go back to Splunk. And so again, this is a search which I have written. So to answer your question, or which you posted, so this is a so here you can see that I'm computing and then telling where it is greater than 4. So I'm setting the threshold value here. So this is where you can do that. And then there's something called throttling, which I was talking about. So I have set it as 2 minutes. So don't trigger an event every wait for 2 minutes. And then if you see my give you actions, you can see that I've set it as monitor traffic.
Right.
And then I've selected it as source IP. So this time I'm going to monitor the source and not the destination. So here, let me just cancel these changes and quickly go back to my incident review.
What size customers are most interested in the inline appliance?
What is the question?
What size customers are most interested in the inline appliance?
It actually varies everybody, right? So it could be from small to large. That's one of the reasons why we've got appliances in different form factors. So
For inline, I'm saying.
inline, yeah.
Yeah.
So typically the characteristic is they often have multiple inline tools. So example could be, for example, a web application firewall, some kind of advanced threat detection system that they want to place inline. But they have more than one tool. Inline tool is when they would be front-ending a Gigamon with that.
I have kind of a general question. So this makes a lot of sense. It's very snazzy if you've already got these two pieces in place, if you're already using this. But would you make a case for people who, what would be the advantage to doing this over a specific application like an IPS, IDS, or any of the other number of things that tackle these same security problems? Why would you go this route if you didn't already have this infrastructure? Would you make a case for that? Or is this more for people who are already deploying these particular applications?
So the reason is because security today is a very complex topic, right? And it's not that you have got one magic wand that you could wave that you could use to solve it. That's where there are going to be multiple tools that are used. The studies that have shown that average large enterprise uses between 40 to 50 tools in an infrastructure. We probably use about half a dozen, I think, in our own infrastructure, right? And we're not a very large enterprise. So it's a complex one. And the things that we are showing here, it's not easy to detect that with a simple IPS, right? Let's do this. In the interest of time, let's wrap up this in the next minute or so,
Just
because
a
we
quick
want to make
question.
sure.
Is it possible to correlate the user information with a flow? Is it user aware? Can I get from LDAP server from some point?
This is something you can do on Splunk. So on Splunk, you can index all the data. So you can take it from the network, you can take it from your database, you can take it from anywhere. You can index all that. And on Splunk, if you see, I did show my search was just taking it from IPFix data.
Yeah.
So there you could add multiple searches. So you could correlate, like take the IP address, go to my domain server, identify who's the user, and then go identify who's the server exactly, and then take action.
Okay, so I can have that in a single view. I can have a single line showing the IP address and the username.
Yeah, so there are two different parts. The adaptive actions which we take is based on the IP address and stuff. What you're talking about is the searches on Splunk. And yeah, we can do that on Splunk. So you could correlate all the databases and bring it in one single table on Splunk. So you could have one dashboard showing all that information you need in single pane.
Okay, great. Thank you.
Thank you.